Have you ever wondered where trigonometric ratios came from and what they mean? For example, the sine of 25 equals 0.4226. What does that mean? In this lesson, you will learn how to define the sine of an angle by looking at similar triangles. Similar triangles have invariant angles. If two right triangles have one pair of congruent angles, then they are similar. For example, we have right triangle A, B prime, C, and right triangle A, B, C. These triangles are similar because they have the acute angle A and because they're right triangles. Also, similar triangles have invariant ratios of sides. Remember, that means the ratios are the same. The sides are different, but the ratios are the same. So if we pull out the orange triangle, we find that BC over AC is B prime C prime over AC prime. You have also learned that the sides of right triangles have special names in relationship to the reference angle. If angle A is the reference angle, then side BC is the opposite leg. Side AC is the adjacent leg, and side AB is the hypotenuse. In the original question, we asked, have you ever wondered where trigonometric ratios come from and what they mean? By replacing the BC AC with opposite over hypotenuse for the blue triangle, and replacing B prime C prime over AC prime of the orange triangle, we arrive at the ratio that looks like this. Again, we know these ratios are equal because the right triangles are similar. But what does this have to do with sine, you ask? To see where sine fits in, it's good to look at the lengths of sides and measures of angles. Let us consider this 30-degree triangle. First, we start by measuring the leg opposite angle A, which is 4, and then measure in the orange triangle the leg opposite angle 30, which is 3. And by reviewing the similar triangle ratio, we see we need to find the hypotenuse. So let's measure the hypotenuse. The hypotenuse of the blue triangle is 8. The hypotenuse of the orange triangle is 6. Let's replace the words with numbers. Opposite is 4. The hypotenuse of the blue triangle is 8. The opposite in the orange triangle is 3. The hypotenuse is 6. Let's reduce those fractions. 4 over 8 and 3 over 6 both reduce to 1/2. So when the reference angle is 30 degrees, the ratio of the leg opposite to the reference angle and the hypotenuse is 1/2, or 0.5. That's a lot to write, you say. You are so right. There is an easier way. The sine of 30 equals the opposite leg over the hypotenuse, which equals 1/2, which is the same as 0.5. So, the sine of any 30-degree triangle will have the ratio of 0.5. The sine of an angle is a constant. What if the angle is different? Because every right triangle with an acute angle of 20 is similar, we know the ratio is always the same. It's a constant. That is what is so great about learning that the ratio is always the opposite leg over the hypotenuse of any given right triangle. The value of the ratio changes when the angle changes, but it is always the ratio of the opposite leg to the hypotenuse. You ask, do I have to have an angle measure to find the sine? No, a common misunderstanding is that you need the measure of an angle. However, if we had A and we wanted to find the sine of A, we just use the opposite over the hypotenuse, which in this example is 1 over 4. Remember, it is a ratio. That is what is so great. If you know the lengths of two sides of a right triangle, you can actually find the measure of the angle. Just have to remember, sine of A is the opposite leg over the hypotenuse, which is 1/4. But that is another lesson. In this lesson, you have learned how to find the sine of an angle by looking at similar triangles.